In this video, we are looking at the process of estimating. In my last video, I gave some examples of where we might use estimation in everyday life. However, I didn't spend too long talking about the mathematical steps that we're actually doing, and that's what I'm going to do in this video. This is Mr. Butler Maths, and in this video, I'm explaining the process of estimating the answer to a calculation. For the rest of this video, we're going to use 4 columns. The first column is the calculation, which is what I'm trying to find the answer to. The estimate is my estimated answer. The answer is the actual answer I would get if I was using a calculator, and in terms of accuracy, I'm interested in whether it's an underestimate or an overestimate, as well as just paying attention to how close my estimate is to the actual answer. Let's suppose I need to calculate 11 multiplied by 4.7, and I'm doing this without a calculator. The process is to round both numbers to one significant figure and then carry out the calculation as normal. If you're a little unsure on the topic of rounding, check out my video on the topic, and that will give you everything you need. 11 rounded to one significant figure goes down to 10, and 4.7 rounded to one significant figure goes up to 5. So my estimate is going to be 10 times 5, because I still do the operation as normal. 10 times 5 is 50, so my estimate is 50. The actual answer is 51.7, so I'm quite close there, but this is an underestimate, because the estimate is lower than the actual answer. For my second example, let's look at 12.5 multiplied by 5.36. Rounding those to one significant figure, my calculation becomes 10 times 5. That's exactly the same estimate as before. 10 times 5 is 50. However, this time, we've rounded both 12.5 down and 5.36 down. So if we've rounded down both parts of our calculation, we can be confident that our estimate is also going to be lower than our actual answer. And we see that is indeed the case. The actual answer to this is 67, which is again an underestimate. Let's change the numbers again. This time, we've got 46.21 multiplied by 4.81. 46.21 to one significant figure is 50, and 4.81 to one significant figure is 5. This time, I've rounded both numbers up, so my estimate, I can be confident, is going to be bigger than my actual answer. Therefore, it's going to be an overestimate. Let's double check that. The actual answer to this calculation is 222.2701. My estimated answer was 250, and that was bigger than the actual answer. Therefore, it was an overestimate. For the fourth one, let's keep the numbers the same, but change the multiply to a divide. So now we have 46.21 divided by 4.81. Again, we're going to round both of those numbers up. So we get 50 divided by 5, and that gives us 10. 10 is our estimated answer. The actual answer is 9.6218, and it goes on a bit longer than that, but we can see that it's quite close to 10. And in this case, again, it's an overestimate, because our estimated answer of 10 is bigger than the actual answer of 9.6218. I've got 2 more examples for you, and they're both going to be more complicated than the ones we've done so far. Let's start with our calculation. I want to calculate 2.813 multiplied by, in brackets, 16.3 add 21.2. Okay, lots of things going on here. The first thing I'm going to do is round all of those numbers to one significant figure. 2.8 rounds up to 3, 16.3 rounds up to 20, because that's one significant figure. 21.2 rounds down to 20, because that's one significant figure. Okay, now I've got my values to one significant figure. I've got a calculation that I can work with. I have to remember my order of operations. I need to do what's in the brackets first. I'm going to add 20 and 20, which will give me 40, and then multiply all of that by 3. 40 times 3 is 120. So my estimate here is 120. What's the actual answer? In this case, the actual answer is 105.4875. So while I'm quite close, it's not the most precise estimate. If I now compare my estimate with the actual answer, I see my estimate is bigger than the actual answer. Therefore, again, this was an overestimate. Let's have a look at one final example. This final example is going to be very similar to the one before, but I'm going to add something to make it even more tricky. This time we've got a fraction. The top part of the fraction, the numerator, is just a copy of the previous example. So we actually already know how to deal with this. So maybe it's not as complicated as it looks. We do still need to work with the denominator. So let's round all of those numbers to one significant figure. We know from the previous example that the top is going to be 3 times, in brackets, 20 plus 20, and the bottom, the denominator, numerator, well, 11.5 rounds down to 10, and 9.83, that's going to round up to 10. So actually, we've gone from something very complicated to something quite straightforward. We already know from the previous example that 3 multiplied by 20 plus 20, that part in brackets, is 120. The numerator in our estimate of this final one is also going to be 120. And we know the bottom, given to us by 10 times 10, is going to be 100. Now, 120 divided by 100 will give us 1.2. The actual answer is 0.9306577, and it carries on going. But we've managed to simplify that very complicated calculation into something much easier to work with, and definitely something you can do in your head. How good is this estimate? It's quite close, and we will see again that this is an overestimate because our estimated answer of 1.2 was bigger than the actual answer. I hope you found this video useful. As I mentioned at the start of this video, you may have come here from my video on rounding or my video on real life estimates where we talked about how much money a cinema makes a day. If you haven't seen those videos yet, I'd really recommend checking those out so you can see how this topic links in with several others. Thanks for watching, guys. As always, leaving a like really helps me out, and don't forget to subscribe if you want to find your way back for more mathematical content.